favorite granddaughter wants me to help with this question. Easy. Let's go.
Okay, let's do question 1. Consider an experiment of tossing 2 coins and rolling a dice simultaneously. Let X denotes the total number of heads, and Y the number that comes up on the die. So as you can see, from tossing 2 coins, you get 4 outcomes, which are heads heads, heads tails, tails heads, and tails tails. So the probability of getting one outcome is 1 over 4. For Y, the probability of getting one outcome is 1 over 6 since there are 6 numbers on the die. Okay, A. We have to construct the joint probability distribution table of X and Y. So for X, there are 3 columns, which are 0, 1, 2. It represents the number of heads. For the rows, Y represents the number of the numbers that are on the die. So first, you have to find the probability of getting one of each, which are 1 over 4 and 1 over 6. Like I said, the probability of getting one outcome from X is 1 over 4. The probability of getting one outcome from Y is 1 over 6. So you just have to times these two numbers and you get 1 over 24. So to get this number, since 0 means there is no heads, the outcome is tails and tails, which is just one outcome. So 1 times 24 and you get 1 over 24 for all of this. Same goes to this part. The outcome is 2, which are 2 heads and heads. This is only one outcome, so one outcome times 1 over 24, you get 1 over 24 for all this. For this part, the outcome is 1 head, which means there are 2 outcomes, tails heads, heads tails. So 2 outcomes times 1 over 24, you get 2 over 24, and when you simplify, you get 1 over 12. For B, find the marginal distribution of X and Y. So we just have to use the joint distribution but add on another row and column. So this represents the marginal distribution of X and Y. To get the marginal distribution, you just have to sum up the numbers to get the marginal. So to get marginal of X, you just sum up these numbers and then you get 1 over 4. Marginal of this, you sum up this number and get this, and so on. For Y, it's also the same. To get marginal of Y equals to 1, you just have to sum up these 3 and then you get here. Sum up these, you get this. Sum up this, you get this. So you get the answers. For C, determine whether X and Y are independent. So to know if X and Y are independent or not, you have to know this. The joint distribution has to be equal to the multiplication of margin of X and Y. So for example, let's use X equals to 0 and Y equals to 1. For joint distribution, we have to find in the table X equals to 0 and Y equals to 1. So here, this is the joint distribution, which is 1 over 24. The multiplication of margin of X and Y, margin of X equals to 0 is 1 over 4. Margin of Y equals to 1 is 1 over 6. So you times these two numbers and then you get 1 over 24. Since these two numbers are the same, which means X and Y are independent. Question D. Determine the mean and variance of W equals to 4X minus 3Y plus 5. So to get mean of X, you have to times the values of X with the marginal. So 0 times 1 over 4 plus 1 times 1 over 2 plus 2 times 1 over 4. So you get 1 for mean of X. For EX squared, it's the same step, but the values of X, you have to square it. So 0 squared times 1 over 4 plus 1 squared times 1 over 2 plus 2 squared times 1 over 4. So you get 3 over 2. Same goes to EY and EY squared. For EY, you just have to multiply the values of Y with the margin of Y. So 1 times 1 over 6 plus 2 times 1 over 6 plus 3 times 1 over 6 and so on. So you get EY is 7 over 2. For EY squared, you have to square the values of Y. So 1 squared times 1 over 6 plus 2 squared times 1 over 6 plus 3 squared times 1 over 6 and so on until you get 91 over 6. For mean of W, you substitute the value of W into the expected value. So you get 4EX minus 3EY plus 5. So you just substitute the values of EY and EX and EY into this equation. So you get negative 3 over 2 for the mean of W. For variance of W, you have to find the variance of X and variance of Y first. So we know that variance of X is EX squared minus EX bracket squared, which you can get 1 over 2. Same goes to variance of Y. Variance of Y is EY squared minus EY bracket squared, which you can get 35 over 12. So to find variance of W, substitute the value of W, and then you can get 16 variance of X plus 9 variance of Y. When you substitute the number of Vx and Vy, you get 137 over 4.
Hello, Grandma. Alright, thank you for helping me. Yeah, I'll see you later, okay? Bye. It looks like my grandma has helped me to answer the first questions. and she asked me to meet her. So let's do a get ready with me while answering question number 2. So to find the value of k, the first thing that we have to do is that we have to use the fact that the total probability of the joint probability density function must integrate to 1. So as you can see there, I did the equation and equaled it to 1. So the first thing that I did was I integrated with the respect to y1 first. So after integrating, the answer that I got was 2y2. And then I have to integrate with the respect to y2. And there I will get k squared. So k squared is technically equals to 1 because that was the total probability. So k equals to 1. So to find the marginal density of y1, first thing that we have to do is that we have to integrate 0 to k f y1 y2 to the respect of y2. So we integrate the previous equation that was given, and as we all know, k is equals to 1. So we integrate it to the respect of y2. After integrating, the final answer for the marginal density of y1, you will get 2y1 to the power of 3 plus 1 over 2. And for the marginal density of y2, you have to integrate it from 0 to 1, f y1 y2 to the respect of y1. And then substitute the fy1 y2 into the equation, and then you have to integrate it normally, and the final answer for the margin density of y2 you will get is 2y2. So question C is to determine whether y1 and y2 are independent. So to determine its independence, we have to check if the joint PDF fy1 y2 can be expressed as a product of the marginal PDFs. So as we can see here, the equality does not hold, which means y1 and y2 are not independent. So to evaluate the joint PDF at y2 equals to 1 over the range 1 over 4 until 1 over 2 for y1 is that first we have to integrate 1 over 4 to 1 over 2 f y1 1 over 2 to the respect of y1. And then by substituting f y1 y2 equals to 4 y1 to the power of 3 y2 plus y2, and y2 is equals to 1 over 2. So the first term, after integrating it, you will get 15 over 512. And then for the second term, you will get 1 over 8, as you can see in the picture. And then you add both terms, you will get 79 over 512. So now we have to find the mean of p equals to 5y1 minus 2y1 plus 8. So what we have to do, the first thing, the most important step, is that we have to separate them to show that we understand the concept. So it will become 5ey1 minus 2ey1 plus e8. And as we all know, e8 equals to 8. So now the only thing that we have to do is that we have to find the value of ey1. So the value of ey1, how to find it? We have to integrate it to the respect of y1. So integrate it, the range from 0 to 1, and then using 2y power of 3 plus 1 over 2 to the respect of y1. And then after integrating it, you will get that ey1 equals to 13 over 20. So you just substitute the value into the previous equation, and then your final answer will be 199 over 20. So now that I'm done, I'm going to see my grandmother to receive the answer from the first questions. And thanks for staying with me discussing about question number 2. I hope you guys understand and can do it later next time. Bye.